name is Flora Noble, and I'm a junior biological engineering major at the University of Arkansas. An interesting fact about me is I used to run cross country and track in high school, and I've ran 2 half marathons. I'm excited to be here today to help you learn more about engineering. Let's get started. Today, I'm going to walk you through the engineering design process as we complete this project. The first component of the engineering design process is the defining component. This is where you define the problem or challenge at hand. Today we're going to work on a project that shows how a hydroelectric power generator works. Several types of engineers usually work on a project like this. A hydroelectric power generator turns mechanical energy into electricity and other forms of energy. Hydroelectric power is produced from water flowing from a reservoir into a turbine that will turn and create energy. Potential energy is what allows the water to flow into the turbine. The water reservoir will be placed at a higher ground and gravity helps bring the water down. The turning of the turbine generates mechanical energy, and this energy is what can be transferred into electricity and other forms of energy. For this project, we are going to use a water wheel as our turbine. This is a good example of how energy is conserved and transformed into different forms. Now let's get into our project. Here are the following materials you are going to need to complete the project. This brings us to the second component of the engineering design process, identify. This is where you identify the constraints and criteria for the project. For this project, one of our constraints are the materials we are limited to. The goal of this project is to demonstrate how hydroelectric power is generated from water at an elevation like in dams and reservoirs. This brings us to our next component of the engineering design process, design. The design component is where you come up with multiple solutions to the problem. For this project, we are going to go through a solution that has already been designed. This brings us to our next component of the engineering design process, the build section. This is where you choose your favorite design and begin to build it. For this section, I'm going to walk you through the steps, so feel free to pause the video at any time to work on your design. First, we are going to make our water reservoir. First, cut open the bottom of the soda bottle. Second, tape the bottle cap shut. Third, poke a hole roughly the size of the straw on the bottle at least 4 inches from the bottle cap. 4. Pass the straw through the hole, leaving the flexible end on the outside of the bottle. 5. Place 2 cups end to end and tape them together. 6. Stand the soda bottle inside the open end of one of the cups. Now we're going to make our water wheel. First, with the popsicle sticks with holes, make 4 plus signs and tape them together. Make sure the center holes are aligned. Repeat this step. When making the plus signs, I used a toothpick to keep the 2 popsicle sticks aligned by putting it in the middle through both holes. This makes keeping them aligned for taping much easier. Second, connect 2 of the plus signs with the center holes aligned with tape. Third, cut the ends off 8 of the spoons and attach them to the ends of each popsicle stick. Fourth, attach the remaining popsicle sticks like in step 2 and tape them to the spoons. Fifth, cut a cup into 2 parts along its length. Sixth, poke a hole the size of a skewer into the same location close to the bottom ends of the cup. Seventh, pass the skewer through the cups and through the water wheel. Once you finish building, the next component of the engineering design process is the testing component. This is where you evaluate your solution. We are now going to test our design. First, place the turbine in a bowl underneath the straw and test that the turbine spins when pushed by the water. Second, ensure all parts of the turbine are within a tub/bowl for easy cleanup. Third, fill the open end of the soda bottle. The turbine should start to move when your water passes the straw level. Fourth, check to see how many rotations the water causes on the turbine from a full reservoir in the soda bottle. This brings us to our next engineering design process component, redesign. This is where you improve your original design. Originally, I planned on having 2 sides of the popsicle sticks laid against the spoons. But after seeing the shape of the spoons and trying to tape it together, I decided to just have 1 of the popsicle sticks and have the spoons more out, like to where the tip of the spoon was attached to the tip of the popsicle stick. Now that we have designed and tested our prototype, we must ask ourselves questions to see how effective our design was. First question, when did the turbine move faster, with more water in the reservoir or less? It definitely moved faster when the reservoir was full. How can you improve on the design? One way you can improve on it is instead of using spoons, you could use like bottle caps, something that has more of a bowl shape, so it collects the water more and it doesn't spill out as much. What are some safety concerns for converting energy between forms? One issue that could happen is if you have electrical energy around water, that could be a big safety hazard for being electrocuted. I hope you guys enjoyed this project and thank you for joining us. For more information about the College of Engineering, please visit engineering.uark.edu.